Hi everybody, welcome to another video in Trigonometry, section 5.4, product to sum and sum to products, identities. So in this section, obviously we have two set of identities. One is the product to sum and one is sum to product. So a product, this one, a product go to a sum, and then the other one, the sum go to the product. Right. But the way it works, of course, there will be four of them, but the way to prove it, we start with this identities. So this is the sum and the difference identity. This is back in section 5.2. Right. So if we have to memorize, if we need to memorize something, I would recommend that you memorize this, and the rest of them you can prove, because if we try to come up with the proof for this, this is non-simple version of the proof. So usually it takes about 10 or 15 minutes to prove just one of them. So, but once we know those, we can derive double angle, half angle, power reducing, sum to product, product to sum, pretty much a lot of things that come from these identities. Right, so I'm not going to prove all of them. You will get the idea. Let's just pick some of them. Let's say the first one. The first one, we'll see that we have cosine plus cosine of u minus v equal to u plus v. So let's start from the right hand side first. So I will try to prove the first identities here. You will get the idea. So let's start with cosine of u plus v. Actually, this is minus first. And the sum and difference identities, we can start from that. So cosine is cosine of u, cosine of v, plus sine of u and sine of v. Right? And then when we have cosine of a sum, it's cosine of u, cosine of v, subtract sine of u, sine of v. Right. After that, we just add side by side. If we add side by side, the side and side cancel out. So we just have 2 cosine of u, cosine of v on the right hand side, but on the left side we have cosine of u minus v plus cosine of u plus v. On the right hand side we have 2 cosine of u and cosine of v. Now if we just want to go back to the product, divide everything by 2, and that's exactly what we have. So divide everything by 2. So we have 1/2 cosine of u minus v plus cosine of u plus v. And divide by 2 on both sides, we just have cosine of u, cosine of v. Of course, that is this equation in reverse. So that's why I said these identities are very fundamental. With these identities, we can derive a lot of other identities. Of course, we can prove the others too. Now let's just prove the last one. Number 4. Yeah. So in this case, we have sine of u plus v and sine of u minus v. So we start with sine of u plus v. It's going to be sine u cosine v plus cosine u sine v, and then cosine of u minus v Sine u cosine v, subtract cosine u sine v. Right, so we subtract side by side. So when we subtract side by side, we change the sign of everything on the second line. So I will do that. Sorry. So change the sign of everything, and we just combine them. So that's like subtracting. So on the left hand side we have sine of u plus v minus sine of u minus v. On the right hand side, those cancel out. Those will be double. And once again, divide by 2 on both sides. And just write the equation in reverse. Cosine times sine is 1/2. Sine of u plus v. Subtract sine of u minus v. Sorry, run out of space. That's what we have. Right. So of course, once again, we can just start from this and just start from either of them, either subtract or add. If we can add them, we can subtract them, and we do this, we come up with 4 identities like this. Next, of course, now we have those identities. We just go ahead and use them. Right. So sine of 15 and sine of 75 degrees. So what is the product of sine times sine? Right, sine times sine, it's going to be that. So it's 1/2. Cosine of u minus v minus cosine of u plus v. So cosine of 15 minus 17, 15 minus 75, sorry. Minus cosine of 15 plus 75. 15 minus 75 is 60 minus 60. And then 15 plus 75 is 90. Now let's simplify. Cosine of 60, before we do that, cosine of negative 60 degree, because cosine is an even function. Meaning that cosine of a negative is equal to a cosine of a positive. So that's just equal to cosine of 60 degree. And cosine of 90 degree, that is 0. So this is 1/2. Cosine of 60 degree is 1/2. So the answer is 1/4. Right, let's check with the calculator. Sine of 7, before we do that, make sure it's in degree mode, which is the case. So sine of 15 degrees times sine of 75 degrees, of course that's 1/4, so it's good. Next, express sine and cosine as the sum or a difference. So sine of 3 theta and cosine of 5 theta. Sine, cosine, so that is this identity, so it's going to be 1/2. See if we can. 1/2 sine of u plus v and plus sine of u minus v. Right, so sine of u times cosine v is 1/2 sine of u plus v, sine of u minus v. So that's exactly what we have. So 1/2. Now sine of 3 plus 5 goes 8. And here we have sine of negative 2 theta. Now, earlier we have cosine is an even function, sine is an odd function. Meaning sine of negative is equal to sine of negative of the sine. So in that case, we have 1/2 sine of 8 theta, and this turns to negative sine of 2 theta. If we want to write as a sum or difference, we just need to multiply it out. 1/2 sine of 8 theta minus 1/2 sine of 2 theta. That's simple enough, right? Right, so that's the first part of it, the product to a sum. So we go from a product to a sum. Now, the next set of identities we have is a sum to a product. So this is a little bit different, right? So how do we prove something like that? First of all, this looks complicated. Actually, I only proved the first one. The rest will be similarly done. Let's try to prove this. Start from the right hand side. Right, so how do we prove something like this? Right, there's only a way to do that. Of course, we can rewrite the cosine x over 2 plus y over 2, and then write that as a sum or product. Yeah, let's try that. Right, so I start with that, and I will write 2 cosine, split this in half. By the way, this may be very complicated. There's another way which is more direct. Right. Now the only problem is, which one do we use? Of course, we end up with cosine of x over 2 and cosine of y over 2. That's what we expect to get. So which identity do we use? By the way, this is just the sum and the difference. So I'm looking at this one. And only one option, so I'm going to go with 2, and then cosine of x over 2, cosine of y over 2, plus, oh, if that is a plus, that will be minus sine of x over 2, sine of y over 2. And then cosine of a difference, also that, but if it is minus, it's going to be plus in the middle. right? And then we multiply them out. This cosine give us the cosine square, and then of course when we do that, let's just skip a step, and when we multiply this, a minus b times a plus b, a square minus ab, actually plus ab first, and minus ab minus b square. So that's just equal to a square minus b square, right? So do that to save some space. We have 2, and we have cosine square this might not actually go anywhere, but and then that minus sine so just cosine that as that. So how did that help? How do we go from here to cosine plus sine? Right, let's multiply the 2 here. Right. Next, what we do is using the power reducing identities. Actually, this is a lot more complicated than I thought, but there's certainly a way to do that. Good reviews. So for cosine square, we can do that, and for sine square, we do that the same thing, right? So cosine square, power reducing, talking about this one. Is 1 plus cosine of a double angle. And then cosine, that's the same thing, 1 plus cosine of y. Minus 2. Sine square is going to be this one. This is not the easiest way to prove. Right. So 2 and 2 cancel out, and we just multiply. Actually, just keep the 4 at the bottom, multiply all the way on the top. I will say sometimes just put all of them over 4. Right, now let's just multiply the 2. 1 plus cosine times 1 plus cosine is going to be 1 plus 2 cosine x cosine y. Plus cosine x plus cosine y. It's better yet, just cancel one of the 2, so we don't have the 2 here. I'll just have the 2 at the bottom. Right, now multiply them out. 1 times cosine, 1 cosine, cosine, and then cosine x cosine y. Next, minus 1 times 1, 1 minus cosine minus negative data plus. Minus 1 is minus, with another minus is another plus. And minus minus data plus with a minus, so minus cosine y. Minus 1 cancel. Cosine x, cosine y, cosine x, cosine y cancel out. So on the top we have 2 cosine x plus 2 cosine y. 2 cosine x plus 2 cosine y. Divide by 2. And cancel out, factor out the 2 first. Divide by 2, 2 and 2 cancel out. That gives us cosine of x plus cosine of y. As mentioned before, this is not the easiest way to prove things. Right, so certainly you can do that. But of course you can also right, or you can do that differently. I just need to find some paper. Right. So that's a good review actually. Now this is a little bit trickery, but will be a lot easier to prove. So we'll try to prove that. Right. What I do here is I will let u equal to this and v equal to this. Right. And then divide it. Yeah, let's start with that. So if u is equal to x plus y divided by 2, and v is equal to x minus y divided by 2, let's cross multiply, and we have 2u is x plus y and 2v is x minus y. How did that help? Well, not there yet, but what I do is I'm going to solve for u and v. Right. So we're going to use that later, but for now let's use the identities that we have, since we start from the right hand side here. 2 cosine of, now we have u and v. Right. And according to the product to sum, this is 1/2. The product cosine u and cosine v is going to be that. So 1/2 cosine of u minus v and cosine of u plus v. So that is exactly the product to sum identity. Product to sum identity. Cosine of u times cosine v is 1/2 times cosine of u minus v plus cosine of u plus v. So now 2 and 1/2 cancel out. We just have cosine of u minus v plus cosine of u plus v. Now we just need to substitute back in. U is x plus y divided by 2. v is x minus y divided by 2. X plus y divided by 2. X minus y divided by 2. Right, and then we just simplify all of them under has 2 at the bottom. So x plus y distribute the minus will be minus x minus negative. That's plus. Now both of them have the 2 at the bottom. So this is plus, sorry. X plus y plus x minus y. Of course, this we have x and x cancel out, 2y on the top. This 1 and y cancel out, 2x on the top. So this is cosine of x plus cosine of y. Right. So by making this substitution, we don't even need that. By making this substitution, turn that into u and v and use the product to sum. And finally, we substitute back in, and that certainly works. Of course, what we did earlier when we do this, that also works, which is a good review of a lot of other identities. That certainly works, like I said, more than one way to do a problem. I'm glad that we cover both of them. Right, now we write this as a product. Now that we have the identities, that should be easy. Sine of 4 theta minus sine of 2 theta. So a sine minus a sine. A sine minus a sine is going to be 2 cosine of x plus y for y plus 2 4 theta plus 2 theta divided by 2, and then sine of 4 theta minus 2 theta divided by 2. 4 theta plus 2 theta, that's 6 divided by 2, so cosine 3 theta. And then sine 4 minus 2 is 2. So 2 theta over 2 is just a theta. That's very straightforward from the identity. Right, so that is sine minus a sine. Now, we have cosine plus cosine. It's going to be 2 cosine of 75 plus 15. And then cosine of 75 minus 15 divided by 2. So we have 2 times cosine of 75 plus 15, that 90 divided by 2 is 45 degrees. And cosine of 75 minus 15 is 60 divided by 2 is 30. So we have 2. Cosine 45 is square root of 2 over 2. And cosine 30 degree is square root of 3 over 2. Cancel one of the 2. And we have square root of 6. So we have 2 times square root of 2 is square root of 6 over 2. Right. Certainly we can verify this, right? It's in degree mode. So cosine of 75 plus cosine of 15. And then if we take square root of 6 divided by 2, we should get the same thing. And we do. So that's what we have. So it's straightforward. Those are the identities. Right. Next, Let's verify the identities. So let's try to work from the left hand side to see if it is equal to the right hand side. So we start with the left hand side. Right. Of course, we use the sum to products identities. So first, on the top, we have the sine plus sine, so it's going to be that. Will be 2 times sine of 5 plus 9 divided by 2. And then cosine 5 minus 9 divided by 2. Right, that's what we have for the top. The bottom, cosine minus cosine is going to be negative 2 sine 5 plus 9 divided by 2. 5 theta and 9 theta, of course. And then sine of 5 minus 9 divided by 2. Right? 2 and 2 cancel out. It's still minus though, still negative. Right on the top, 5 plus 9 is 14 divided by 2, so it's 7. Sine of 7 theta. And then cosine of 5 minus 9 is minus 4 divided by 2, so minus 2 theta. At the bottom, sine 5 plus 9 is 14 divided by 2, so that's 7 theta. And then sine of negative 2 theta. Next, cosine is even, sine is odd. So cosine of even, meaning cosine of a negative, is equal to cosine of a positive. Sine of a negative equal to negative of a sine, because sine is odd. So at the bottom we have an extra negative sign. We should see that they cancel out already. Because that cancel out, cosine of negative is cosine of positive. Because cosine is even. And sine of a negative is a negative of a sine. And finally, negative and negative cancel out. We just have cosine over sine, which is cotangent, which is good. So that identity is true. Right. Next, I'll verify this identity. Well, of course, look like the left-hand side is a more complicated sign. Now, if we're going to add them like this, 1 plus 2 divided by 2 is going to be a fraction. But notice that on the right hand side we do have the sine of 2x. So in that case we want to leave the sine 2x alone, and we'll try to combine the sine x and the sine 3x. And then I will leave the sine of 2x by itself. I just combine these two. Right, sine plus sine. So what is a sine plus a sine? A sine plus a sine is 2 times sine x plus y divided by 2 and then x minus y divided by 2. So we have 2 times sine of x plus 3x divided by 2, and then cosine of x minus 3x divided by 2, and we still have the sine of 2x untouched. X plus 3x is 4x divided by 2, so that will be 2x. And then here cosine of x minus 3x. Right? Sine of 2x. And then we have cosine of x minus 3x is minus 3x. X minus 3x is minus 2x divided by 2, so we have minus an x. Right? So that gives us 2 sine of 2x. Once again, cosine is even, so cosine of negative is cosine of positive. And then factor out sine of 2x. Common factor, factor it out. Left with 2 cosine of x plus 1. Now, is that the same as that? Obviously not. So in this case, this is not true. So there's not an identity. So this one is not true. Alright. Yeah, so this didn't say prove it. It say verify, so it may or may not be true. The first one though is true. This one is not true. So the first one is an identity. This one is not. Right. So that's all I want to cover for this section. So in this section, there's only 2 identities: a product to sum, and then sum to product. So, as always, thank you for watching. See you in another video in trigonometry.